Okay, so warm up is practicing a Unit 6 skill, so multiplying binomials. Table 5, you could either tell me the final answer or you could tell me what you get when you first multiply the first one. X squared minus 16 as the final answer is correct. Earlier, some of the answers I heard were just like x squared or 0 is what they told me. This, you can use an area model, which I think I'll do for this one, but you also could have done like the double distributing, the foiling, but all you have to do to set up your area model is take like one parentheses, put it on one side, separated by the terms, the other parentheses on the other side, separated by the terms, and then find each individual area. So like x times x is x squared, x times -4 is what class? X times 4 is, and 4 times -4 is, and then at this step, we see if there's any like terms to combine. Typically, it's the x terms, and combine means add. So what's 4 plus -4? So these cancel out completely then. Tristan, put it away, last time reminder. So this blank you could fill in as this, just kind of like for the work shown. I mean, the area model is also work shown. I just don't think you were able to necessarily see it in there. And then these two middle terms canceled, which makes the x term go away completely. The other terms don't cancel though, they're still there. Questions on that? Okay. Then table 6, what would be either the final answer or the first line for the second problem?
Minus 5 and 5
minus 5m plus 5m. And then what was the last thing you said? Okay. So that, I mean, I don't have room to show you area models for all of them. So like if you did the FOIL method, so multiplying the first terms, 5m times 5m is 25m squared. Multiplying the outer terms, 5m times -1 is a -5m. Inner terms, 1 times 5m is a positive 5m. And then our last term in each parentheses multiplied together, 1 times -1 is -1. And then combine like terms, that would be the -5m plus the 5m. What do I get when I combine those class? 0, because they cancel out completely. -5 plus 5 is 0. 0 times m is 0. So this cancels out completely. My final answer is 25m squared minus 1. All right, and lastly, table 8, what would be either this first line or the final answer for the last one? Table 8. So unless you're using the calculator to do like 2 times 2 or 2 times -3, the calculator really won't help you much. So like the calculator won't tell you what A times A is, or what A times B is, you'd have to be able to tell you that. So. Do we have the any part of the answer? Okay, well then let's do the double distributing. So table 8. What's 2A times 2A? What's A times A? Good. So 2A times 2A is 4A squared. It shouldn't just be A, because the only time like you can multiply and it doesn't change at all is if you're multiplying by 1. So like A times A has to be something different. So that's me distributing just this to that. We still need to distribute it to the negative 3B. So table 8, what's 2A times negative 3B? Positive or negative? So doing this one to that one should be a negative, so the positive times a negative. So negative 6, and then what's A times B? Good. Right, we're not gonna like pick a random other letter. We're not gonna like make anything squared or anything because they're not the same letter. We just write them next to each other when that's A times B is AB. All right, table 9, I'll have you distribute this to the rest. So what's 3B times 2A? Good, and it's positive, so I'm putting a plus 6AB. And then distribute what's 3B times negative 3B. Close. 3 times negative 3 is, no, we're multiplying, not add. So 3 times negative 3. Good. So that is negative 9B squared. And then we're gonna combine like terms. But any questions on just that first part, just to multiply? All right. Well then, at this step, we see, are there any like terms to combine? Do I have any variables that are exactly the same? Yeah, I have 2 terms with A and B, like A to the first power, B to the first power. So these are like terms. Class, what's negative 6AB plus 6AB? 0. So these 2 terms cancel out completely because they're the same number but opposite sides, right? So then our final answer for that one is 4A squared minus 9B squared. Luckily, because we're dealing with quadratics on the test, probably won't seem much higher than like something squared. But notice like what each of these 3 problems have in common. What happened in every single one? All of you. What do those 3 problems have in common? What happened in every single problem? Yes, Tristan?
There was like term.
There were like terms that did what in the end? That added to 0, so they canceled out completely. Normally, when we do these, multiplying binomials, remember we would usually get like a 3-term answer. This time we're just getting a 2-term answer. And also notice something else in them. They're all subtraction problems. That also is perfect squares on each side. So our answers for each of these are what we call a difference of squares. So if you see a 2-term expression where there's subtracting in between them and they're perfect squares on each side, So like the x squared, the square root is x. 16, the square root is 4. 25m squared, the square root is 5m, and so on. That's the difference of squares. The reason that's important is because they have their own way of factoring. So like if you see a 2-term, can't do the diamond method with a 2-term expression. You have to use something else, like a different format, but it's still factorable, it's still solvable. That's what we're gonna focus on today. I'm gonna read you the learning targets, but any questions on the warm-up? So that's really how you would check your answers, is multiply it back out and see if they'll be the original. But now the problems are gonna look more like this, and we're gonna factor them to get this. Okay, so what we'll do today. We are on lesson 8 of unit 7, which is looking closely at some special kind of factors. So we've been factoring a lot. We've been doing like trinomials, we've been doing by GCF. What we're covering today, difference of squares, is just another one of those things. The thing you're supposed to do is be able to identify them to know how to factor them. So if you see something that has no linear term, meaning no b value, like it's just x squared plus c, then you see if it's a difference of squares. And then when it's factoring, it'll look something like this, where they're basically the same exact parentheses, but one has a plus and one has a minus. So by the end, you'll be able to explain why multiplying a sum and a difference results in an expression with no linear term. Kind of already saw that in the warm-up. It's because the linear term cancels. And then being able to factor that like the other goal. I'm recording right now. The lesson updates every year, but the math is the same. Like math usually doesn't ever change. So you could always get ahead. You could always work backwards. There's a video there, no matter if I'm absent or you're absent, like it's always there. There's no excuse to not have your notes done. The practice today is on paper. So when you do finish it, you'll take a picture, you'll upload it. I do want to see work shown. I don't want to see just answers. Granted, today's method doesn't have a whole lot of work to show, except for maybe once you get to that second part of your paper. But I should not see just answers on the whole thing. And how do I know you didn't this? So you have to show work, upload it to school if you're done. We are getting very close to our Aspire math. So that means that if you were wanting to do this for extra credit, like the deadline's coming up, you have to have it done by like Monday night, basically. So there's that. Same with the IXL skills. If you were wanting to get some of that extra credit, or if you've had some and you just haven't submitted them yet, you want to do that before your ACT Aspire math on. So get that submitted. And we do have a quiz today, so however far we get by around, I'd say 10:10, we'll stop and take the quiz. Questions on anything I said? So yeah, back to this. So we're gonna learn how to go from an answer or a problem like this to an answer like that. So first, what you have to do is make sure you are given a difference of squares. So that would have to be a 2-term expression. And what does difference mean in math? It has to have the subtraction sign in between those 2 terms. So difference. And squares are something that can be something times itself. So like x squared would be x times x, that's a perfect square. And then of course, if you're not sure if something's a perfect square number-wise, try it out in your calculator. But for these, since it's a difference of squares, you're not going to want to put the minus signs. Okay, so like For example, number 1, check to see, is that a difference of squares? Is it a subtraction sign in between them? Up here? Is this a difference of squares? Is there a subtraction sign in between them? Are they both perfect squares? What's the square root of 8 squared? Come on, guys, in order to factor this, you need to be able to tell me if something's a perfect square or not. What's the square root of 8 squared? A. Because guess what? A times itself gives us A squared. That's why it's a perfect square. Is 4 a perfect square? What's the square root of it? Good. Square root of 4 is 2. So hang on to that for a second. Because if it's a difference of squares, then you apply this rule where you are taking the square root of each perfect square and writing it in the factor form where one has a plus sign and one has a minus sign. So if you look at our warm-up, the ones that were given to us originally, they're almost the exact same parentheses, except one has a plus, one has a minus. So if you have a difference of squares, which we established, number 1 is the difference of squares, the factor form will be this. A plus 2 times A minus 2. Those being my square roots. And then it says check your work by distributing. If you were to multiply this out, this is what you would get initially with the 2 middle terms canceling out. So yes, that is correctly factored. That makes sense? Good. Okay, let's try a couple more together. Let's look at 3. So first, it needs to be a difference of squares if we're able to factor it. So everyone look up here. Is this a 2-term expression? Does it have a minus sign in between them? And are there perfect squares on each side of the minus sign? What's the square root of 81? And that's a 9, not an A. What's the square root of x squared? So then we can use the difference of squares rule, which says that the factor form is like that. We're going to do 5 next, if you have questions. All right, so number 5, first, check to see, is it a difference of squares? Is it a 2-term expression? Is it a difference? Is it a minus sign in between them? So it's not a difference of squares. I'm gonna abbreviate, not a difference of squares. So in that case, see if it's factorable by GCF, because really you should be checking for GCF first. Anyway, in any situation, but like I'm looking at it, there's no GCF between the coefficients, like 1 and 25, no GCF there other than 1. And they both don't have a K. So when they're not factorable by any method, we call that prime. So number 5 is prime. We can't factor it by a difference of squares. We can't factor it by GCF. It's already like, I don't know how else to describe it. There's nothing we can do. Question on that? Okay, I'm gonna give you a couple to try on this one. So try number 6 and number 9. So just try those. And then we'll go to the back together after we go over them. So I'll give you about a minute or so. So table 3, please tell me, is number 6 a difference of squares? Is it a two-term expression with a minus sign in between and perfect squares on each side? Then it should be factorable using that rule that we wrote up here. All right, so I need the square roots of each. Class, what's the square root of 1? Good. So then following this method, 1 should be to the front of each parentheses. A plus and a minus follows. And then class, what's the square root of 49y squared? 7y. So take the square root of 49. Again, you check your calculator for that. Square root of y squared, you just kind of have to know that. Like, what will give you y squared? And that's y. We're gonna look at other types of exponents on the back, but first we'll do number 9. Any questions on this one though? All right, as far as switching the order, like you can put, if you wanted to, the minus sign here and the plus sign there, that doesn't change anything at all. But as far as switching the order in the parentheses, like some people really just want to see that 7y first. If you do that, you cannot change the signs of any of the numbers. So like this is still a negative, the 1 is still a positive. This over here is a positive 7y, the 1 is still positive. But I just don't see why anyone would want to do that. So just like leave it in order. Questions on that? Anyway, number 9, table 5. Is number 9 a difference of squares? So then what would be the square root of 16a squared? Okay, good. And then the square root of 121. So then for your factored form, it should look like this, with one of those parentheses having a plus and the other one having a minus. Good. And then let's go to the back side. So granted, this unit is quadratics. We know that quadratics need to have like something squared. So you're probably not going to see stuff like this as much. But if you ever see an exponent that's higher than 2, the way you know if it's a perfect square is if it's an even exponent. So, for example, number 14, let's look at that together. This is a difference of squares. So let's take the square root of each term. What's the square root of 81? And then for the n to the 4th power, what times what will give me n to the 4th? Good. And there are other ways to get n to the 4th, but we want it to be like something that could be multiplied by itself. So like n squared times n squared is n to the 4th. Basically, like divide that exponent by 2, and then that's going to get. So then this is the square root of 81 n to the 4th. What's the square root of 25? So then one of the parentheses will have a plus 5, the other one will have a minus 5. So that. Okay, well then I'm gonna have you try I want you to try 15 and 17, and then we'll do a couple of more examples after there together. But try 15 and 17 for right now. In order to use that rule, it needs to be a two-term expression. So is it a two-term expression? Is there a minus sign in between the terms? And are they perfect squares on each side of the minus sign? No. 5 is not a perfect square. Everything else is, but the 5 is not. Earlier, I asked for the square root of 5, and someone said 2.5. 2.5 times 2.5 would be something else. I think it's like 4.25. So 5 is not a perfect square because when you try to find the square root of it, you get a long decimal that goes on forever. It would need to be a whole number to be a perfect square. So, see if it's factorable by DCF. It's not. Like they don't have the same variable, the coefficients, the only common factor they have is 1. So 5 is actually, yes. Okay. Oh, okay, you're late on it. All right, go ahead, help yourself. Now over here, 17. First check, is it a two-term expression? You're welcome. Is it a difference? And are they perfect squares? So then you can factor it using that method. What's the square root of k to the 6th power? K cubed. K to the 3rd power times k to the 3rd power will give us k to the 6th power. So basically just divide that exponent by 2, and that'll give you what it has to be to multiply by itself. So make one of these a plus, one of these a minus, and what's the square root of 16? So that is the answer for 17. Good on that? Okay. So then scrolling, let's talk about GCF again real quick. The GCF is what we did that Kahoot on the other day. You guys may or may not have all been here, but we did a Kahoot on just like briefly touching on that subject. Really, you should be checking for a GCF first anytime you're having to factor, and then look at what remains and see if it's something else that you recognize that could be factored. And you might even see that on your quiz too. Like, you know how we've been doing the diamond method on like trinomials? Well, really, you should check for a GCF first, then look at the parentheses and then see if it's still factored. So let's look at 21 together. Luckily, your homework tells you when it's a GCF, factor it out first. So like right here, I'm looking at my terms. There is a GCF between 2 and 72. What is it? What's the greatest factor that they have in common? So 2 and 72, what's the GCF? 2. First of all, 2 doesn't have that many factors. It's just 2 and 1. And your GCF can never be bigger than the smallest number. So see if that smallest number is the common factor. If it's divisible into both numbers evenly, then it is a common factor. So 2 is my GCF. They both don't have the same variables, so I can't factor out any variables right now. But I can factor out a 2 from each. So that will go outside the parentheses. Inside will be what we get from dividing each term by the GCF. So I'd have n squared minus 36. Then look at what you have in the parentheses. See if that's anything you recognize. Since it's a two-term expression, I know the only way to factor two-term expressions are by difference of squares. So is it a difference of squares? In the parentheses? Is it a subtraction problem in between? Are these perfect squares? Then I can apply that rule from earlier. The only difference now is you have a GCF on the outside, so it still should be in your answer. The rest, apply that difference of squares rule. So what's the square root of n squared? And what's the square root of 36? So then one of my parentheses will be n plus 6, the other one will be n minus 6. And then here's my final answer. The GCF just living outside the parentheses. Good. Can you guys try 22 and then we'll take the quiz? Try that real quick. Okay, for time purposes, we'll start going over 22. But you're supposed to look for a GCF and factor that out first. So between 18 and 50, what's the greatest common factor between them? 2 is. So it can never be bigger than your smallest number. So C, does 18 divide evenly into both? It doesn't. 50 divided by 18 is not a whole number. So then start thinking of factors of 18, and I would probably start with like the larger ones. So like 9 times 2, 6 times 3, and then I think that's it. Aside from 18 and 1, which we already canceled out. So like 9 is not divisible into both. 6 is not divisible into both. Neither is 3. So my greatest one that they have in common is just, that makes sense. GCF will live on the outside. Inside, you need to divide each term by the GCF. So 18x squared divided by 2 is 9x squared. Negative 50 divided by 2 is 25, a negative 25. And now check your parentheses. Is my parentheses factorable? It's a two-term expression, so check. Is it a difference of squares? Miss Medina. Okay, no problem. All right, it is a difference of squares. So you find the square root of each term, set it up something like this, where one of them has a plus and the other one has a minus, but they're the same parentheses otherwise. All right, square root of 9x squared is 3x. Square root of 25 is 5. So then this would be the final answer. All right. So you have a quiz. Go ahead and pull that up in Schoology. I'm going to tell you the password. You can use notes. You can use your own scratch paper.